Hi, so we have question number 2 of the exercise. In this next question, we are asked to evaluate the terms given in the index notation. As you can see, these are the terms and the expressions that we are given, and we have to evaluate the terms given in index notation. To evaluate an expression with an index, we first expand the index as repeated multiplication, and then we calculate the result. So in here, taking a start with the first one, we have 10 with the index of 4, so it means 10 is multiplied in 10 appears in multiplication 4 times, so 10 multiplied by 10 multiplied by 10 multiplied by 10, which is equal to 10,000. Then the second one, as you can see, 7 raised to the 7 with the index of 3. So 7 being the base, it means 7 is the number appearing in multiplication 3 times. So 7 multiplied by 7 is equal to 49. 49 multiplied by 7 is equal to 343. Then we have 6 raised to the power of 7, or 6 with an index of 7. So 6 is multiplied, or it appears in multiplication 7 times. 1, 2, 3, 4, 5, 6, 7. So we multiply them and find the numerical value of it. 4 raised to the power of 9, or 4 with an index of 9, it means 4 appears in the multiplication 9 times. So what we do is that we expand that index as repeated multiplication, as you can see, and then we calculate. So we get 262144 as the numerical value or the result. Then we have 10 raised to the power of 5, or 10 with an index value of 5. So we expand the index as repeated multiplication, and then we calculate the result. Again, 1 with the index of 12, we expand the index in as repeated multiplication, and then we calculate it. 1 multiplied by itself even 1,000 times, it will be always 1. Then we have 2 raised to the power of 10. So 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2, it goes 10 times, because when we expand the index, it means we have to express it in repeated multiplication of the base value, which is 2 in here. So 2 appearing in multiplication 10 times, if we calculate it, we get 1024. Then 9 raised to the power of 4, again we expand the index as repeated multiplication, so we get 9 multiplied by 9 multiplied by 9 multiplied by 9, which is equal to 6561. Then we have 2 raised to the power of 6, or 2 with an index of 6. So in here, as you can see, we again expand the index as repeated multiplication, and then we calculate the result. Then in here, the next one is we are having 2 terms in this expression, 2 raised to the power of 8 and 3 raised to the power of 2. So each one is expressed separately, or each index is expanded as repeated multiplication of the base value, which is 2 and 3 in here. So 2 is appearing in multiplication 8 times, and 3 is appearing in multiplication 2 times. So we express it as it is, and then we calculate it, which is when we multiply 2 8 times, we get 256, and 3 multiplied by 3 we get 9, and then when these two gets multiplied, we get 2304. O is again, like we are having 2 terms in this expression. The base value is 5 and 3, and the index is 3 and 5. So 5 base is expressed or appears 3 times. So accordingly, the index is expressed or expanded in repeated multiplication. And also the same is applied to 3. Then we do the multiplication. 5 multiplied by 5 multiplied by 5 is equal to 125. and 3 multiplied by itself 5 times equal to 243. So these two gets multiplied, and then the final result when calculated is 3375. Then we have again two terms in this expression, in which the base value is 2 and 3, and the index values are 3 and 4. So we expand the index of each base value according to the number or the value of the index. The index for the first base 2 is 3, so we accordingly expand the repeated multiplication, and for 3 it is 4 times, so again we expand the index according to the value it has. So 8 multiplied by 81 is equal to 648. 5 raised to the power of 2 and 3 raised to the power of 8. So 5 is multiplied or appears in multiplication 2 times, and 3 appears in multiplication 8 times. Then we calculate the result, we get 16,425. In here 4 with an index of 5 and 2 with an index of 6. So when index is expanded as repeated multiplication, 4 expands to 5 times appearing in multiplication, and 2 is expressed or appears 6 times in multiplication. Then we calculate it and we get 65,536. And the last one we have 2 raised to the power of 6 and multiplied by 3 raised to the power of 4. So in here the base values are 2 and 3, and the index is 6 and 4. So we will be expanding the index for the given basis, and then we will be calculating. So this is all for this question. All that you have to keep in mind that when we are asked to evaluate an expression with an index, we need to find its actual numerical value, which has been 5,184, 65,536. These are the numerical values of these expressions with index, which we have evaluated and found the numerical value of it. That's all for this question. Happy learning.